When you ask yourself, are the benefits of Vulkan even worth it when it's so complicated? That's the right video for you. After months of OpenGL, I spent the last 2 weeks trying out Vulkan, and in this video I will be going over my top 4 takeaways. In the end, I will be giving my exact opinion on which API you should learn, if you should learn more than one, and if I will be continuing learning Vulkan, and that without any it depends. Let's directly start with takeaway number 1. Vulkan uses a lot of very abstract terms. I knew going into this that I would have to deal with a lot of niche, low-level terms, but I wasn't prepared for the amount of depth of those. For example, when you configure the vertex shader, that's the shader that deals with corners of your triangle you are about to render, you have to set some S-type to vcase, structure, type, pipeline, shader, state, create info. To be honest, even as a German I'm scared of those long words, and we use ones like Infleischetikettierungsüberwachungsaufgabenübertragungsgesetz, which just means the law of saying who has the duty to supervise the labeling of beef. Just like the translation, the meaning of the line is pretty simple. It's setting the type of a truck so the API knows what the following data is about. But the problem with Vulkan is that you have to write hundreds of those very abstract lines, so that in the end the hardest part isn't writing code, it's learning the vocabulary. Number 2, this is similar to takeaway number 1, but it makes it even worse. If you don't know explicit, just means that you have to say very directly what you want to happen. For example, the opposite is when you declare boolean in Python and you don't have to write bool is done equals true. Instead, the interpreter recognizes that you want a variable of type boolean instead of a string with the value true, and does the rest. In theory, I like explicitity. That was one of the points why I wanted to try out Vulkan in the first place. But it gets very complicated if you don't just have to set variable types, but instead have to exactly define every little part about rendering. In this example, you have to explicitly state the order in which the rendered frames get displayed. One present mode can introduce latency, a different may not be supported. Others are more likely to introduce screen tearing, and others to get the point. It's just really annoying having to configure and look up a bunch of things you wouldn't have noticed for a long time before you can even render your first triangle. Number 3, that's something I actually like about Vulkan and hate about OpenGL, and that is that OpenGL can feel very unreliable when you write it. This is how you compile a shader in OpenGL. You first create an ID for your shader, then you combine that ID with the source code and call it GA compile shader with that combination. What I hate about this is that your shader is just an unsigned integer and there isn't any strong structure behind that. Like you could do math with that. S1 divide by 2. I know later in production code that won't happen, but unlike Vulkan, it's a repeating theme that everything in OpenGL feels a little breakable. Finally, number 4. The main reason I wanted to learn Vulkan was good error handling. When I first saw how you have to deal with errors in OpenGL, I almost got a heart attack. The following code is from learnopengl.com. Probably the best way to start learning about OpenGL, and it's directly below the code snippet you just saw. The idea of a shader being an unsigned integer. After you call GA compile shader, you have to catch the info log about an unsuccessful compilation in the char array, then print it out. Compared to Vulkan's efforts, the validation layers and more, OpenGL makes me feel like I am an actual caveman hitting rocks against each other in the hopes of making fire. Nonetheless, you have to keep in mind that your graphics programming and black screens without any errors are still coming. For example, when I followed a tutorial series for Vulkan and got to the point where the window should appear, it didn't, even though the console output was identical. By the way, if you stumble about that, the solution for me was to continue the tutorial until you set up more of the API. Because, according to ChatGPT, my display manager doesn't show empty windows or something like that. So, should you learn Vulkan as your first graphics API? No, of course not. I would even say it doesn't matter how experienced you are with programming and how well you understand hardware. It doesn't hurt spending a weekend, maybe even just half a day, hopping on OpenGL, understanding the high-level structure of where the input comes from and where it has to go to render a triangle. After that, you can always rush Vulkan in 2 weeks, like I did, to see if it's for you. For me personally, I found out that if I want to use graphics API, I will use OpenGL or something even more high-level. After all, the reason I tried graphics programming is to have the opportunity to experiment with things like pathfinding, particle simulation and more, without having an entire game engine around me with a bunch of code that I don't understand. OpenGL gives me the opportunity to do that with minor abstractions, while Vulkan makes me feel like I'm making the engine with the code I don't understand. And if you now want to try OpenGL or Vulkan, I have linked to the material I have used in the description. For OpenGL, that's the getting started section of learnopengl.com, and for Vulkan, I recommend the Vulkan game engine series Series by Brandon Gallier. I hope I pronounced that correctly. In addition of explaining Vulkan, he also explains some fundamental graphics programming concepts with hand-drawn diagrams, but I still highly recommend you to read the written tutorial on vulkantutorial.com, because not all Vulkan functions get explained in depth. I hope my insight has solved whatever question you had about Vulkan or graphics programming in general. If you still have one, feel free to leave a comment and I will try to reply as soon as possible.